All right, fifth graders, so we're still going to use some multiplication with fractions, and we're trying to remind ourselves what multiplying by a fraction does to the product. Remember, the product means the answer to a multiplication problem. So we're starting off with 3 examples. Let's take a look at each of them. So first, we're going to compare the products to the 2 meters, because we're starting with 2 meters in each of these problems. So let's notice what happens to 2 meters when we multiply or scale 2 meters by other factors. So these numbers here, these are the scaling factors. So let's see what each scaling factor does to the 2 meters that we start with. So without evaluating, without sitting down and working it out and solving it, which expression is going to be greater than, less than, or equal to 2 meters? Well, let's see. This one here, 100 100ths, that's the same as 1. So I know if I multiply 2 meters by 1, I'm just going to get 2 meters. So I know that one's equal to 2 meters. This guy, that's greater than 1, 101 100ths, so that's going to be greater than 2 meters. This one here, 97 100ths is less than 1. And I know if I multiply something by less than 1, then I'm going to end up with a product that is smaller. So it'll be smaller than the 2 meters we started out with. So we're going to rewrite these two real quick. So our first one is 2 times 97 hundredths. And then we have 2 times 1 100th. And then finally 2 times 1. So now finish this sentence. To get a product that is less than the number you started with, multiply by a scaling factor that is less than 1. So list 3 decimal scaling factors that would make this number sentence true. 2 times blank is greater than 2. Okay, so I know if I want to multiply and get something bigger than 2, then I have to multiply by something that's bigger than 1. So I'm going to say 1 2/10, because that's bigger than 1. And how about 3 1/10? And you give me the third. You give me the third scaling factor that would work for this, any scaling factor bigger than 1, and then come see me for a smelly star. Then we finish this sentence. To obtain a product that's more than the number you started with, multiply by a scaling factor that is greater than 1. Greater than 1. So here we have 2 different multiplication expressions. Both of them start with 19 4/10, but multiply it by 2 different scaling factors. So we're going to ignore this for a sec. So look at the first expression. Will the product be more than, less than, or equal to 19 4/10? Well, are we multiplying it by something that is less than 1, or greater than 1? 96 hundredths is less than 1. So our product will be less than 19 4/10. Now look at the second expression. Will that product be more than, less than, or equal to the 19 4/10 we started with? Woo, that's way less than 1. So again, less. So to write it as a number sentence, we're going to say 19 4/10 multiplied by 2 hundredths is less than 19 4/10. Let's make my decimals a little bigger. So we know that both scaling factors will result in a product that's less than the number we started with. So which expression will give a greater product? Why? So which is going to end in a larger number? If we multiply it by 96 hundredths, or if we multiply it by 2 hundredths? 96 hundredths. The bigger the number we multiply by, the bigger our product in the end. So we know that 96 hundredths is the larger number, which will give us the larger product. So what's the scaling factor for problem 2a? So for problem 2a, right up here, the scaling factor is again 96 hundredths. What would the scaling factor need to be in order for that product to equal 19 4/10, to equal what we started with? Well, the scaling factor would have to be 1. So is 1 the same as 100 hundredths? Yes, it is. So this scaling factor, 96 hundredths, is just slightly less than 1. It's so close to 1, but not quite there. Is that true or false? That's a big fat truth. So if this is true, if it's really close to 1, what can we say about the product of 19 4/10 and 96 hundredths? We know it's going to be really close to 19 4/10, because 19 4/10 times 1 would be 19 4/10. So times almost 1 is going to be almost itself. So really close to 19 4/10. So let's think about how we could model problems like this. So if we draw a tape diagram for 19 4/10 times 1, it would look like this. So this would be 19 4/10, and here's our 1. Since 96 hundredths is just slightly less than 1, this means that 19 4/10 times 96 hundredths is slightly less than 19 4/10 times 1. The tape diagram should be slightly shorter than the first one we drew. So the expression 19 4/10 times 96 hundredths is just slightly less than 19 4/10. So draw a second tape diagram slightly shorter and label it. So we're going to go like this. So we have 19 4/10 multiplied by 96 hundredths. So they're almost the same size, this one and this one, but this guy is just slightly smaller because it's multiplied by a smaller scaling factor. So now we're being asked to make a statement about this expression. Is 19 4/10 times 96 hundredths slightly less than 19 4/10 or a lot less? It's only slightly less, just a little bit less. So now look at the other expressions. Is the scaling factor 2 hundredths slightly less than 1 or a lot less than 1? 2 hundredths is a lot less than 1. 2 hundredths is darn close to 0, so we're going to say a lot less than 1. So now we're going to do two tape diagrams. So this one, this is 19 4/10 times 1, and this one, this is 19 4/10 times 2 hundredths. Way smaller. So let's make a statement. Is 19 4/10 times 2 hundredths slightly less than 19 4/10 or a lot less? Way less. So now we're going to compare two more problems. So we're going to consider the first factor to be the scaling factor, 1 2 hundredths and 29 1 hundredths. So we're going to write the scaling factors in the order they're given to us. So they're given to us in the order 1 2 hundredths and 29 1 hundredth. So let's think about these expressions. Will the products be more than, less than, or equal to our original factor? Our original factor is 1 73 hundredths. Well, let's see. For A, the scaling factor is 1 2 hundredths, and that's super close to 1. So I know that multiplying anything by 1 is itself. So my product, since I'm multiplying it by something very close to 1, is going to be very close to itself. So I'm going to say really close to 1 73 hundredths. Now for B, I'm multiplying it by 29 1 hundredth. That's really close to 29 and nowhere near 1. So this is going to make my product way larger than what I started with. So much, much larger than the 1 73 hundredths that I started out with. So I want you to answer these on your own, in your own words, and set that timer for 3 minutes. If this is taking you longer than 3 minutes, come see me. Good luck.